Okay, welcome to day 1 of combination of functions, section 1.8. So the first thing we're talking about is the arithmetic combination of functions. It just means we're combining functions using arithmetic. So this is two functions that have been combined using addition, subtraction, multiplication, or division. Something else we also want to look at is the domain of our combined functions. The domain, it's going to be all real numbers of f and g, f of x and g of x, that are common to the domains. One further restriction is going to be when we're talking about division, which is given as f of x over g of x. Obviously, g of x, let me write this down here, g of x cannot equal 0, because we know we can't have a denominator that equals 0. That would make it undefined. So we're going to be looking at our sum, difference, product, and quotient. So these are all named for the output. When you add two numbers, like f plus g of x, you get a sum. And this is going to be rewritten as f of x plus g of x. Then difference. When you subtract, you end up with the difference. This becomes f of x minus g of x. Product, f times g equals f of x times g of x. And then finally quotient, f divided by g of x equals f of x divided by g of x. Alright, so we're going to start on sum. Okay, so sum of functions. Remember, sum is addition. So if we're given f plus g of x, that can be rewritten as f of x plus g of x. Now I'm going to use the same functions throughout all the examples. F of x is equal to 7x minus 5, and g of x equals 3 minus 2x. So the first thing, when we add, we're going to rewrite. So we have 7x minus 5 plus 3 minus 2x. Then we can simplify, and we get 5x minus 2. If you were asked simply to evaluate f plus g of x, this is where you would stop. If we're going to go one step further and actually evaluate it 4, we would replace our x with 4. So it gives us 20 minus 2, which evaluates to 18. Now we have difference. Okay, there we go. So this is given as f minus g of x, which can be rewritten to f of x minus g of x. So if we use our given functions, we're going to rewrite f of x is 7x minus 5 minus 3 minus 2x. Notice that I put my second function in parentheses. This is to remind me that I need to distribute that negative across. because that is one of the most common mistakes that we see. So when we rewrite this, we get 7x minus 5 minus 3 plus 2x. Okay. We're simplifying, and when we continue simplifying, we get 9x minus 8. So if you're asked to evaluate f minus g of x, you would stop here. But if we're going to go one step further and evaluate it 4 using the same number, we'd have 9 times 4 minus 8, which gives us 36 minus 8, which evaluates to 28. All right, so we've done sum, we've done difference. Next one is products. The product of a function means that we're multiplying our two functions together. So we have f times g of x, which expands to f of x times g of x. Okay, so when we rewrite this, this now becomes 7x minus 5 times 3 minus 2x. You can use whichever method you like to expand this out. I'm just going to do straight distribution. So 7x times 3 is 21x. 7x times negative 2x is negative 14x squared. Then we have negative 5 times 3 is negative 15. And then negative 5 times negative 2x is 10x. So once I combine and reorder, I get 14x squared plus 31x, x minus 15. So if you were asked just to find f times g of x, this is where you would stop. Then to evaluate one step further, we would replace so this gives us negative 224 plus 124 minus 15, which evaluates down to negative 115. Notice, I am evaluating and rewriting I'm not evaluating before I rewrite the functions. I always rewrite to get my simplified function, then I evaluate. All right, let's move on and look at difference. It's not difference, quotient. So I'm getting ahead of myself, I'm getting behind myself. All right. Quotient of functions. And our quotients are outcome when we divide, so that means we have f times g at x, which is written as f of x times g of x. We want to pay attention to our domain restrictions. Oh, barely. Okay. So if we are given our two functions, that means we have 7x minus 5 over 3 minus 2x. Now there's nothing we can simplify. This is as simple as it gets because we have a term on top and a term on bottom. These terms don't match, so we can't cancel anything out. We do need to look at our domain restriction. So we take our denominator, set it equal to 0, and solve for x. So as long as x doesn't equal 3/2, then we're fine, and I promise I won't ask you to evaluate that. So if you were asked for f divided by g at x, that's where you would stop. But if I want you to evaluate at 4, then we would replace our x's with 4. and figure out what we have. That gives us 28 minus 5 divided by 3 minus 8, which evaluates to negative 23 fifths. So that is the quotient of our given functions when we evaluate at 4. Okay, so that is everything that we are looking at today. That has been, I can't spell. This has been combination of functions. 1.8 day 1. So your classwork tomorrow, we're going to look at page 89, 1 through 23, odd. Okay, and then your homework tomorrow, I will see you back here for 1.8 day 2, combinations, not combinations, compositions. Compositions of functions. All right, see you tomorrow.